Welcome everyone to Ecology Live. I'm Mark Cadott, editor of the BS journal, Ecological Solutions and Evidence. If this is your first time joining us, you're very welcome. And welcome back to all those that have been joining us regularly. You can check who is still set to speak on our website. And while you're there, why not sign up to receive our newsletter and find out more about everything else the BES does. It's my great pleasure to introduce Alex Moore for today's talk. But first, we would like to thank Wildlife Acoustics for the wonderful soundscape that started this session. We would also like to thank Oxford University Press, who are sponsoring the whole season of 12 talks. You can find details of their Ecology Live reading list, which includes discounts and some free content at the slide at the end of this talk. This talk is being recorded and will be added to our YouTube channel afterwards. Importantly, you can submit your question via the Q&A box at the bottom of your screen throughout the talk. There's no need to wait to the end. And there'll be a short question and answer period at the end of today's talk. Your questions can be named or anonymous, you decide. You can also upvote any questions you find particularly interesting by clicking the thumbs up icon. This helps me to moderate the questions. So today it's my great pleasure to introduce Dr. Alex Moore, who is currently an NSF postdoctoral fellow at the American Museum of Natural History. Alex examines how predator-prey interactions influence the health and functioning of coastal wetland ecosystems, and has recently expanded to exploring the cultural and societal implications of habitat restoration. Alex has also been extremely active in science outreach, education, and mentoring, and towards building a more just and equitable ecological science. Today, Alex's talk will convey the incompleteness of our understanding of coastal wetlands and how we move forward with their conservation and management. Over to you, Alex.
Perfect, thank you. So just give me 1 second here. All right, hopefully you should all see this. Wow.
That's great.
Perfect. So again, thank you for the introduction, and I also want to thank you all for being here virtually. So today I'd like to address the question that's in my talk's title. So what do we actually know about coastal wetland ecology? And as I hope you'll see by the end of my talk, it's not as much as we should. So to start, what I'm showing you here is a map of the global distribution of wetland ecosystems, where the green represents the wetlands themselves and blue represents inland bodies of water. So thinking about lakes and rivers and things of that nature. As you can see, wetlands can be found on nearly every continent on the planet, but it can actually be quite difficult to clearly delineate them because their definition and their boundaries are quite broad. So the simplest definition of a wetland is land that is wet, and that doesn't really tell you very much. So there are actually numerous kinds of wetland ecosystems, some of which are shown here. So these examples include marshes, fens, swamps, peat bogs, and a variety of other ecosystem types. Now, given just how vast this category is, I'm going to focus on coastal wetlands in today's talk. And so these can be grouped into 3 broad categories, which are salt marshes, mangrove forests, and seagrass beds. They are found in both tropical and temperate regions across the globe and make up less than 1% of Earth's total surface area. Now, wetlands are incredibly important ecosystems that provide numerous functions and services. Shown here is a non-exhaustive table of some of the ecosystem, hydrological, and economic and cultural services that these ecosystems provide. And now, in addition to these services, wetlands also have significant economic value. A paper came out in 1997, which was updated in 2014, where researchers assigned a dollar value to the services provided by global ecosystems. And what they found is that wetlands provide functions and services valued in the trillions of dollars annually. So what this means is that if we go back to that map that I showed you of the global distribution of wetlands, if we were to delete all of the green off of that map, so to remove every single wetland from the planet, it would cost humans trillions of dollars every single year to provide ourselves with the same services that wetlands provide just by their existence. So given the services that they provide and the value of those services, it should be clear that wetlands are incredibly important. Now, given how important they are, one might assume that we have a pretty detailed understanding of how they work. It turns out that we do know quite a bit, but we don't know nearly enough. And so over the next several slides, what I'm going to do is walk through a history of what we know, and notably what we don't know about coastal wetland ecology. So our story begins in the mid-1950s with seminal studies in coastal salt marshes and mangrove forests in the United States that aimed to evaluate ecosystem productivity and energy flow. And so here, researchers were looking at the different producers, the herbivores and the carnivores found within these systems. And then they were noting, as energy is now flowing within this system, how is it being distributed and utilized by the different components found therein? And so what I'm showing here in this left-hand figure is a schematic from 1962, where a researcher was evaluating this input of energy and then trying to show visually how is it being distributed amongst all of these different components. And so these studies measured or calculated productivity, decomposition, and consumption for various important species that are found within coastal systems. And from this work, an ecological paradigm describing coastal wetlands was developed. What these early researchers concluded was that the tides are responsible for the large amount of plant biomass production and the production of detritus within these ecosystems. And so they noted that the structural aspects of coastal wetlands, including things like species richness, plant distribution patterns, and overall productivity, were maintained primarily by abiotic processes acting from the bottom up within these ecosystems. And so examples of these processes included the frequency and duration of tidal flooding, salinity, and then sediment characteristics. So these physical factors within these ecosystems. And it's this narrative, one that really emphasized the relative importance of physical and bottom-up features within these wetlands, that persisted through the 90s and into the early 2000s. However, studies in New England salt marshes at the turn of the century challenged these early results. So researchers observed a decline in salt marsh extent due to the overconsumption of vegetation by herbivorous crabs found within these ecosystems. And that's highlighted in this first photo here on the left, where you see the salt marsh system, you've got this creek, and this edge of that salt marsh extent has no vegetation left in it. And that's sort of migrating up the ecosystem. And so this was due to the consumption of vegetation by herbivores within this system. Now, these observations are contrary to those seminal studies that said that consumers and biotic factors don't play a significant role in maintaining ecosystem properties. And so given these observations, what followed were experimental studies that aimed to evaluate these top-down factors. And so these other two photos here in this slide are from one such study where experimental cages were established across these salt marsh ecosystems that prevented predators from accessing those spaces. And so the idea here was to really see what would happen in the absence of this top-down control within these ecosystems. These studies found that consumers and top-down processes significantly influence salt marsh ecosystem structure and function. Specifically, runaway herbivory and burrowing due to the purple marsh crab, so that's this photograph shown here, due to the absence of predator control, facilitated the loss of wetland extent across these New England salt marshes. And so this is a figure from a paper that came out in 2014, where they're noting this linear relationship between the percentage of herbivory that's being observed and then the percentage of die-off that's experienced across the landscape. And so as herbivory increases, so too does the loss of those ecosystems. And so what I actually want to point out in a schematic here is just a detail of how this really plays out in practice. And so what we can see here, the schematic is showing sort of a cross section of a wetland ecosystem, salt marsh ecosystem, where you've got the creek on this lower edge and then the salt marsh sort of working its way up from there. And as you can see, what they're showing you here is that you've got herbivory happening across this landscape, both above and below ground, because these burrowing crabs are able to consume vegetation in both of these areas. And so given the absence of vegetation, both above and below ground, you no longer have that root structure that provides stability across the landscape. You also now have all of these these burrows that make that portion of the landscape even more unstable. And so what happens is as herbivory increases across these areas, that sediment becomes very unstable. It caves in and then falls off into the creek. And so that can continue over and over again as herbivory moves up the marsh surface. And this can lead to the overall loss of that wetland ecosystem because it's physically falling into the creek bank and is no longer able to produce vegetation that helps maintain that structure. And so these observations and these experimental studies are really highlighting how the studies that focused primarily on those physical features originally weren't taking into account the role that consumers might actually play across these systems. So what we're seeing now is that consumers are important across these landscapes, and this warrants additional investigation. And so currently we are in a period now where it has become increasingly evident that consumers play an important role in wetland functioning, and that the evaluation of these top-down and also the combined top-down and bottom-up impacts has increased over time. However, the studies of these top-down features are far less common than those that are still evaluating exclusive bottom-up control. And that's being shown here in this figure, where researchers really took a compilation of all of the studies available in wetlands that are evaluating different features, and they're dividing up how many papers are published every year within these systems that are studying bottom-up control, which is being shown by the dark black line, top-down control, which is the white line, and then a combination of the two, which is the gray line. And as you can see, we significantly have a larger number of studies that are looking at bottom-up control exclusively, and far fewer of the studies that we have in terms of looking at the ecology of these ecosystems focus on these top-down or the combination of the two across these landscapes. And so given the lack of comprehensive studies that have taken place looking at these elements, we don't really have a good understanding of the extent to which these top-down features might be important within these wetland ecosystems. And so to address this lack of information, a recent meta-analysis was conducted to address this knowledge gap, to really ask the question, what is the overall impact that consumers and top-down factors have in maintaining coastal wetland ecosystems? And so in this analysis, researchers evaluated the impact that consumers have on the structure and function of different plant communities. And so what I can show you here is a figure from that particular paper where they're looking at a diversity of different consumer species, so insects and snails and crabs, waterfowl, and a number of other species, and evaluating what is the impact that they are having on a number of different vegetation features across these landscapes. And what they found is that even looking through this diversity of consumer species that can be found across these different landscapes, these consumers are having largely negative impacts on several plant features, including plant survival, reproduction, biomass, height, and a number of other features that were evaluated. And so from this study, it's been concluded that consumers really do drive global vegetation dynamics across these coastal wetland systems. And so in work that I've been able to do, I've also shown that these kinds of impacts are context dependent. And so this is a figure from a paper I published back in 2018, where I was looking at different variables impacted across the salt marsh landscape within 3 New England coastal wetlands. And so what I'm showing you here is just one of those variables in particular. So looking at biomass production across each of these landscapes at these 3 different field sites in the presence or absence of different consumer species. And just from looking at each of these 3 panels, you can see that the impacts are different across these different locations. So the effects that consumers are having on vegetation in one site are not necessarily going to be the same impacts that we're seeing consumers have in another site. So there's a lot of variation that can also take place here, but we are still seeing that these consumers are playing an important role across these ecosystems. Another thing to note here is that all of the studies that I've mentioned so far have largely focused on vegetation impacts, so the way that consumers are influencing vegetation. But what about other ecosystem functions? What other properties might consumers be influencing within these ecosystems? So to answer this particular question, my students and I conducted a literature review looking at all of the studies evaluating the impact of consumer presence or absence on properties other than vegetation within coastal wetland ecosystems. And so this table here is just a summary of what we were able to see. So from all of the studies that we were able to find, that we're doing evaluations of presence or absence and then seeing the impacts of those on certain features, we broke it down by what habitats were these studies focusing on, what were the consumers that they were looking at, and then what were some of the response variables that were measured across all of these different studies. And what we found is that salt marsh ecosystems were the ones that were by far the most evaluated across the different kinds of coastal ecosystems available. We saw very few studies that were evaluating mangrove habitats, and we didn't see any studies that were looking at seagrass beds in terms of the roles that consumers have on non-vegetation properties across the system. So that's one thing worth noting. We're seeing this significant ecosystem bias in the ways that we are evaluating these coastal systems. Another takeaway is in terms of the consumers that were being evaluated. Across the vast majority of the studies that we collected, much of these were focusing on macroinvertebrates, so crabs in particular, and then also livestock in terms of the roles that they're playing in influencing different dynamics across the system. And that was really it. We didn't see very many other species being evaluated. And this focus on macroinvertebrates and livestock is probably due to the fact that we're also seeing studies only occur in salt marshes, because these are the kinds of species that we typically see across those landscapes. And now another thing worth noting too about the consumer element is that these studies usually only focused on one trophic level. So the presence or absence of one type of species and how it might influence outcomes across that ecosystem. We didn't see any studies that were looking at the dynamics that might occur when you have multiple trophic dynamics within the system and the interactions between different species that are found in these habitats. And so that is not being incorporated, even though these are natural processes that do occur within these ecosystems. And then finally, we noted that there was just an oversaturation of variables with a variety of different metrics that couldn't be compared to each other. So we're noting here that there's a number of different things that are being measured beyond vegetation, but we can't compare them across these studies because they aren't comparable. So we can't generalize impacts that consumers might be having because there's just far too much variation in what people are evaluating across these ecosystems. So hopefully, as you can see here, there are significant gaps in our knowledge of the ecology and the functioning of these systems that need to be filled in. And so an important question that I think follows from this is, what does it mean? So these knowledge gaps are bound to have numerous implications. And one significant one that I think we should be thinking about is in terms of the roles that they might play in the conservation and the restoration of wetland ecosystems. Wetlands are among the most threatened ecosystems across the globe. We know that between 35 and 57% of the world's wetlands have been lost since the 18th century. And there are a variety of different reasons for these losses, but three main factors include land conversion, so taking something that once was a wetland and turning it either into agriculture or urban development. Another variable is climate change and the associated sea level rise that is leading to the loss of these ecosystems. And then another feature here that is more prominent more recently is the removal of species and how that can have these cascading effects that lead to the loss of these ecosystems. And so given that we know that these are really important ecosystems and they are threatened globally, significant efforts to restore them have taken place. However, most restoration efforts don't really meet stated goals. And so I'll sort of say this in a more simplified manner, but restoration goals are typically twofold. One is to make sure that the restored wetland is better functioning than its degraded state. And then the other is to see if we can get restored wetlands to function just as well as natural ecosystems that haven't been significantly altered. And so to highlight how we can sort of tell whether or not we're meeting these goals is I'm showing you a figure from a paper that came out a little while ago where researchers did a global evaluation of restored wetlands, and they compared them to both degraded ecosystems and then also compared them to natural ecosystems by measuring several ecosystem services. And so what I'm showing you here in this first panel is the comparison between restored wetlands and degraded wetlands at several ecosystem services noted here all the way right on the left. And so just to orient you to the figure itself, they're looking at effect sizes. So that 0 mark means that the restored wetland is functioning just as well as a degraded wetland. Negative values mean that the restored wetland is underperforming compared to the degraded. And then positive values indicate that the restored wetland is performing better than the degraded wetland. And so as we can see in this panel, across all of the ecosystem services that were being measured, the restored wetland performed better than the degraded wetland, which is great news. It means that we are able to recover services through restoration projects relative to unhealthy degraded conditions. But that's only part one of the narrative. We also have to think about what are the ways that these restored wetlands might compare to natural wetlands that have been minimally altered. And that's what's being shown in the second panel. And so again, 0 means equal performance, negative values mean the restored wetland is underperforming compared to natural wetlands, and then positive values indicate that the restored wetland is performing better than natural wetlands. And as we can see in this case, restored wetlands on average have reduced function compared to natural wetlands at the majority of the different kinds of ecosystem services that can be measured. And so this gap that we're seeing between restored wetlands and natural wetlands might be due to our incomplete understanding of these dynamic systems and the ways that that influences how we attempt to restore them. So traditional wetland restoration efforts can include a variety of different steps depending on the context and the kind of habitat and the history of the region. But most efforts still maintain at least these 3 stages, which include the removal of the disturbance. So whatever caused the problem, removing that before moving on to additional steps, rehabilitating the soil and then improving the hydrology of the system, and then restoring vegetation. So really providing that physical habitat for species to return to over time. And as you can see, the focus of most restoration efforts really is on these physical features. So providing habitat and making sure these bottom-up features are sort of addressed in order to improve services. And this is largely due to that historical ecological paradigm, which is now having a legacy that informs how we perform restoration. And so across these kinds of efforts, we're seeing this focus on bottom-up features. So the nutrients, the hydrology, and soil characteristics to inform how we restore these ecosystems. But we're not seeing a focus on these top-down biotic factors such as predation and herbivory, non-consumptive effects, and other different things happening across that system that may also be able to influence the recovery of certain services. And so the idea I think that we should be sort of pushing for is moving away from this idea that it's only focusing on the bottom-up features, but rethinking restoration approaches in such a way where we're still incorporating these physical features that we do know play an important role across these landscapes, but then potentially incorporating the biotic elements that might also aid in the recovery of certain ecosystem features across these landscapes. And so I think in order for us to do this well, and also just to generally understand how these ecosystems function, we have to fill in the knowledge gaps that persist. And so for me, I think that that means looking at a lot of the different features that have been highlighted earlier. So this includes understanding the context dependency. So we know that certain features are changing in one location that are not necessarily changing in another location due to the role that consumers are playing within these landscapes. And so understanding those contexts to give us better predictive power, I think will be incredibly important. Another is to incorporate these trophic interactions. So not only focusing on one type of species group, but really thinking about interactions between these higher order consumers across these landscapes and the ways that that might have cascading effects across these landscapes. I also think that we need to move away from this dichotomy of bottom up versus top down, because we know that they both play a role. And so studies should really be thinking about what are the nuances and the interactions between these, and how does that inform the way that these systems function? And then beyond that, just in terms of the research that's being done itself, I think we have to incorporate broader ecosystem properties. So moving away from solely focusing on vegetation, but also incorporating the other kinds of processes like decomposition or nutrient cycling that are occurring within these ecosystems. And then finally, we need to look at more than just salt marshes. Coastal ecosystems are incredibly important across their range, and incorporating mangroves and seagrass beds and all of these other coastal systems, I think will really broaden the way that we can understand how they work. And so one last thing that I do want to add here is, in addition to filling in these ecological knowledge gaps, I think it's important that we also move towards incorporating the social and cultural elements and the uses of these ecosystems. We know that across a variety of habitats that cultural values and uses play an important role in land use practices and also can inform conservation and restoration practices. And so if we want to really understand how these ecosystems work, we need to include knowledge and values of the communities that have historically shaped and interacted with these ecosystems. And so this means that we need a better and more holistic understanding of these ecosystems, and that this requires embracing diverse knowledge systems in order to improve the way that we engage in both ecology and in conservation. And so with that, this is sort of me wrapping up the talk. So I want to thank you all for being here, and I look forward to answering some of your questions. And for those I'm not able to get to, I've also added my Twitter handle here where you can find me online, and I'm happy to engage more in these topics beyond this event. So with that, thank you again, and I will stop sharing my screen.
All right, thank you very much, Alex. That was a fantastic talk. Really interesting work. So let's get into some of the questions. There's a bunch of questions coming in. I'm certain we're not going to be able to get to all of them. And so as Alex generously indicated, there's an opportunity to engage on Twitter afterwards. So I'll go right into some of the questions, and I might jump off the questions and ask one of my own that I really want to ask you. So first question comes from Camilla Bertolini. And they're asking about if we started harvesting salt marshes for human needs, in particular Salicornia, could that have similar impacts to natural grazers? Is there a way to incorporate some human impacts? And I wonder then, linking to the very end of your talk about social cultural use, is there social cultural uses of wetlands that could serve as sort of this type of herbivory effect?
Oh, absolutely. I think that it kind of depends on the degree to which the take from the ecosystem mimics the way that the herbivores are also performing in the ecosystem. So oftentimes you'll see that people are harvesting from the soil surface up, right? So they're just taking that biomass from the top, which means that you do maintain some root structure that's happening beneath the surface that can maintain stability of those landscapes. And so if we're thinking about the roles that humans can play in terms of how they can also negatively impact the system, they can certainly do the same thing, just at, I think, a much larger scale than we're so far seeing the consumers do within these ecosystems.
Great, thanks. Another question from Shailin Prado, and they're asking about the contribution of paleo-ecological research on wetlands. So I know, for example, there's a lot of paleo-ecological work done from bogs and wetlands. Can this help inform understanding wetland ecology and maybe help inform restoration?
I mean, I want to say yes. I think that right now, I think it's quite clear that there's a lot that we don't know. And so going further back in time, I think can provide us with a lot of context that can help inform how these systems have been changing over time. And I also think that it can help put into context how we are thinking about restoration. Like most of our restoration efforts are a little bit backwards focusing or looking sort of, where we are right now. But I think we should be also thinking about what are the ways that these systems might be changing due to global change and other novelties that are persisting across these systems, and really be forward focusing in a lot of our efforts instead of looking back in time to try to mimic what we used to have and think about how can we maintain function moving forward.
Great, thanks. Question from Bob Holt, who's done a lot of work on trophic interactions. And he's asking about wetlands having conspicuous zonation, and how much of that can be explained by bottom-up effects versus top-down processes that might be generating these spatial patterns?
Yeah, it's a combination of the two. And so in my talk, I've really been sort of focusing a bit on top down in terms of consumption. So like having that be the role that species are playing within the system. But there are really important ecosystem engineers, which I didn't talk about here. And so we know that the fiddler crab, for example, has this burrowing behavior that makes certain elements or areas of the marsh better for plant growth. And so in the areas where you have, a large population of these fiddler crabs that are performing their ecosystem engineering effects, you see better growth growth of vegetation. And then as you move further up the landscape where you don't have these crabs present, you see a very different set of species that are present up there. So you're seeing this zonation that is informed both by, these consumer effects or these sort of biotic effects, and then that also is being impacted by the more physical things. So the tides coming in, how far up the landscape do the tides go? How is that draining nutrients or bringing nutrients into the system? And so that zonation is being influenced by both the bottom up and the top down features.
So I'd like to ask my follow-up question because it kind of relates to that. So I think a lot about terrestrial systems, and I think about restoration in terrestrial systems. And one of the issues I have trouble wrapping my head around and thinking about is when we're restoring a system, we're often restoring, as you said, the physical characteristics, the vegetation. We're often actively planting vegetation, but those are activities that happen at a fairly small spatial scale. But when we start thinking about multiple trophic levels, we're talking about organisms that might experience the environment through dispersal or foraging or other activities at a very different spatial scale.
Mm-hmm.
So how do we align those spatial scales to ensure that what we're doing in restoration can be of value to those other trophic levels that are also important for the functioning of those systems?
Yeah, and that is, the question that I also, worry about and wonder about, because I recognize that most, as you say, most restoration efforts are really focused on a finite region, a finite space. And you have these other species that are moving beyond and out, throughout all of those spaces. I think that it really requires thinking about restoration as being more than about, we need to fix this one tiny little area, and think about how does this one small space fit within the larger context in which the system is found. Because we know that especially in these coastal systems, nothing is static, or nothing is sort of, stays the way that that you see it in one moment. It's always very dynamic. It's always changing. And I think that we have to do a better job of incorporating those dynamics and all of the different variables that come into it, which makes everything harder, but I think also makes it more realistic. And that's a thing that I think we have to try to balance. And I don't know that we have a great answer for it right now.
Yeah, thanks. No, I appreciate those thoughts. There are a bunch more questions, but I am cognizant that we've gone beyond half past the hour. So I'm going to encourage people who we can get you to address their questions and on Twitter, or they can engage with you on Twitter as well. And I really appreciate all the questions and everyone listening. And I really want to say thank you, Alex. That was a fantastic talk. I really enjoyed it, and thank you for being with us today.
Yeah, no, absolutely. Thank you for the invitation. And again, thank you all for being here virtually.
Thanks a lot. Okay, so that brings our Ecology Live to an end for this week. Next week, at the same time, we'll have Maria Ardenas from University of St. Andrews, who will talk about how global compilations of biodiversity data are unveiling a nuanced picture of biodiversity change. If you're watching the recording on YouTube, but would like to join future live talks, make sure you register for Ecology Live on the events page of our website. This December, we're looking forward to inviting ecologists from around the world to join us at Ecology Across Borders 2021, our joint annual meeting with the French Society for Ecology and Evolution. We are also excited to announce that the call for thematic sessions and workshops is now open, with a deadline of 1700 BST on Wednesday, the 26th of May. You can find out more information on our website via the link that's posted in the chat now. Finally, I'll leave you the details of an offer from our sponsor of today's Ecology Live talk, Oxford University Press. You can use the discount code on the slide and in the chat to receive 30% off their Ecology Live reading list, which includes the book Ecology of Coastal Marine Sediments. Thank you for joining, and see you again next Thursday.